Hello guys, so today we are going to do a past paper for 2017 past paper for MAT 1510. Past paper is for MAT 1510. So this is mathematics. I'll just call it maths. So the first question says function f and g are defined by, we have our f of x, which is equals to 1 over absolute value of 1 minus 3x. And then we also have g of x. So our g of x, I'm going to write it separate. Let me just first explain about this function, which is our f of x. So this function, which is f of x, it have an absolute value of 1 minus 3x. And you must remember that you can write an absolute value as 1 minus 3x if your x, 1 minus 3x, is greater than 0, or you can write negative in brackets 1 minus 3x if your 1 negative in brackets negative, let me just use negative there, negative in brackets 1 minus 3x is less than equals to 0. So this is how you do. So the graph of the original graph of an absolute value, remember, is drawn like this way. So when it's drawn like that way, it have x, it have negative axis, and it also have a positive axis. So now when we have that in mind, so the questions that want us to determine the d, they want us to determine the df. So df means the domain. This means domain. To those who don't understand it, it means domain of f. Domain of what? Of f. So now when we want to determine the domain of f, so we know that because of the function is 1 over absolute value, so this absolute value, which is 1 minus 3x, it must not be equals to 0, because if it's equal to 0, which means the denominator, if it's equals to 0, the function is going to be undefined. So if it's not equals to 0, so this means that our 1 minus 3x is not going to be equals to 0, and this implies that our minus 3x, minus 3x, let me just take it out properly. Okay, our minus 3x is going to be not equals to what? Minus 1. So which implies that our x is going to be not equals to 1 over 3. So remember, based on the graph, this graph goes like this way. So it takes the positive and the negative. So the df, when you write it, the df, the domain of f, you can write it as is an x element real number, x like that, element real number, given what x is not equals to 1 over 3. So just by writing this, you have written the domain of f. Sometimes you can write the domain of f as f equals to a negative infinity into negative what? It must be in an open x element negative infinity. Let me just write it properly. You can just write it as x. It's an x element what? Element negative infinity into negative 1 over negative 1 over what? Negative 1 over 3, and then union, you must union them because they are union. Then after that, when you union them, is going to be negative 1 over 3 into infinity. So just by doing that, you have answered. So this side here, it must be negative. It must be negative. The reason part, it must be negative is because of if you put, okay, there is in part that equation, okay, sorry, this equation I just made a mistake. It's not supposed to be negative, it must be positive, ne? Positive, positive, and positive. Not there, I mean in x there, it must be positive, it must be positive value. So that's how you find the domain of what, of the that function of f of x. So now let's go to the function for g of x. For g of x, you are given that a g of x equals to log, it's a log 1 over 3, log 1 over 3 in brackets 1 over, okay, it's 1 over 3x what, minus 2 minus log x, minus log of x, so minus log 3x, sorry, 3x 3x. So now you have this function, you have to find the domain of this function. So the first thing that I'm gonna teach you guys is that, remember, you can write this 3 as, we can rewrite g of x, we can rewrite g of x as equals to log of 3 to the power negative 1 in brackets 1 over 3x minus 2 minus log of 3x. So now we can write this one can come on top. So when it comes on top, it can be negative log of 3 in brackets 1 over 3x minus 2 minus log of 3x. So this one, it can be written as equals to, because of negative, we take out negative outside, it will be log, this one is just the matter of, I'm showing you some ways of trying to make it 1, the 3x minus 2 plus what, plus log of 3x. So you know that these two, they will multiply each other. It's going to be negative in brackets log of 3 in brackets 1 over 3x minus 2 multiplied by x. So now when you have this, so you can, we're gonna rewrite it in as one thing. So now you have already solved, we just try to solve it, but we are not yet getting the, what, getting the domain. But when we get a domain, we can separate, use the same. So in the logarithm, when you get a domain, if you have log of x like this, your x, it must be greater than 0. So which means now for those two, when we solve them in that equation, we are going to take the, remember there is a base and exponent, so we are going to take 1 over 3x minus 2, let me write it properly, 1 over 3x minus 2, it must be greater than 0, and our x there for log 3x, it must be greater than 0. So now when we have this, if we split it again, we're going to have a 3x minus 2, it must still be greater than 0, it must be greater than 0, and our x, it must be greater than 0. So now it implies that our x must be greater than 2 over 3, and our x must be what, must be greater than 0, still greater than 0. So now when you have this, then you can write, which means because x is greater than 0 and is greater than what, 3 over 2, this implies that your x is going to be greater than 2 over 3. Then for your dg, your domain of g, you can write it as x element real number given that into such that x is greater than 2 over 3. So you have written the domain of f of g. So now when we move, you have to solve the inequalities. Say, for example, if you have to solve f of x when x is greater than 2, your f of x, you know, is that your f of x is 1 over absolute value of your f of 1 minus absolute value of 1 minus 3x, which means it must be greater than 2. Now, so when we solve that, we know that if we swap them, it's going to be absolute value of 1 minus 3x. It will be greater than 1 if we swap them 1 over 2. So here it's like we are changing this, it comes over, like it's over 1 like that. So now when we solve it like that, you can see that this equation is now very much simpler. And take into account when you swap them, this sign here, it must change, so it must be less than. So when it changes, now is then we can define, you know, that based on the absolute value it must have a negative part and a positive part. So now what is going to happen, we're going to have our negative here. You're gonna say our negative 1 over 2 will be less than what, 1 minus 3x, which is less than what, 1 over 2, the positive side, because absolute value of x is less than 1. If absolute value of x is less than 1, this means that minus 1 is going to be less than x, which is less than what, which is less than 1. So we are using this rule there. That's one. So now you can solve it. You just take the other one. The other side is going to be minus 3 over 2 is less than minus 3, which is less than what, you take the other one, is going to be minus 1 over 2, then 3x, sorry, then you divide by 3, negative 3. When you divide by negative 3, remember now when you divide by, it's going to be 1 over 2, going to be less than x. 1 over 2 divided by 3 is going to be, divided by 3 is going to be 1 over 6 is less than x, and x is less than, you divide by 3 multiply by is going to be less than 1 over 2. So now when you have done that, you have solved it, and you have solved that f of x when x equals to so. So this is an inequality. In another way, inequality. This is an inequality. So you have solved it, equality. You have solved it, this problem. So this is how you solve such problems if you have them, especially on terms of inequalities. So let me erase here and write it properly. It's 1 over what, 6. Yes, and let me also erase here so that you can see this is negative here, 3x, which is less than. Yeah. So you can revise them, check them, and then you're gonna understand, practice them. Practice makes more perfect. So sometimes you can be given a question to solve a question. Sometimes you can be also given to solve like, for example, let me say if a question they ask you to solve for a g. So g, you know that it was already g of x. You are not solving, you are simplifying. Your g of x was log of 1 over 3 into 1 over 3x minus 2 minus what, minus log 3x, log of 3x. So to simplify this, if you want to simplify, okay, to simplify, then we gonna separate them. I'm gonna just write equals to, you can say this is the same. I already did this, I'm just repeating so that you can see. Until the end is 3x minus 2 minus log of 3x. So this is going to, because of this negative, you take it out, it's going to be negative log of 3 1 over 3x minus 2 3x minus 2 and then minus log of 3x. So this is going to be equals to, take out the negative, you're going to be left with log of 3 in brackets 1 over 3x minus 2 minus is going to be plus now because we take out the common factor as negative 1, log of 3x. So this becomes negative equals to, according to the base, according to the laws of logarithm, you know that is going to be log of 3 in brackets 1 over 3x minus 2 close brackets, you brackets close brackets. So now when your final step is just the matter of equals to log of 3x in brackets, what you can just put even brackets if you want, brackets 3x minus 2. So you have simplified, this is, you have simplified it. So this is how you simplify the equation. So thank you guys, subscribe to this channel if you like these kind of videos, educational videos, academic videos. Subscribe, share with your students, classmates, and then let them get to know this channel. Thank you. Bye.